Welcome back to Classified Files, the channel that declassifies the most astonishing, untold stories of military history. We often think of war as a clash of steel and firepower, of tanks, ships, and airplanes. But beneath that visible conflict, there has always been a second, invisible war, a war of signals, of codes, and of the electromagnetic spectrum. In this shadow war, victory and defeat are measured not in miles of territory, but in decibels, frequencies, and the capture of a single flickering signal that can change everything. Tonight, we go back to a moment of supreme crisis, when a nation's survival hung by a thread and the enemy seemed to possess an almost supernatural ability to strike with pinpoint, devastating precision, even in total darkness. The conventional tools were failing. The experts were baffled. But one quiet, overlooked scientist, assigned to analyze the junk data from a new, buggy, and universally hated piece of technology, saw a pattern that everyone else had dismissed as random noise. His superiors called his theory a fantasy. His colleagues called it a career-ending obsession. But his pursuit of that failed signal led to a discovery that didn't just save his country from disaster. It fundamentally changed the future of warfare forever. This is the failed radar that saved Britain from disaster. Before we power up the transmitters, if you believe that the most critical battles are often the ones fought in secret, in laboratories and listening posts, by men and women whose names are rarely recorded, then I need you to join our intelligence network. First, hit that subscribe button and activate the notification bell. It's your clearance for all future declassified briefings. Second, hit that like button. It boosts our signal and helps these vital stories reach a wider audience. And finally, drop a comment down below. Let us know what country and city you're receiving this transmission from. Our global network of history and technology enthusiasts is our greatest asset. The year was 1940. The world was on fire. France had fallen, a staggering, catastrophic collapse that had left Britain standing utterly alone, a defiant, terrified island fortress against the seemingly invincible might of the Nazi war machine. The Battle of Britain was raging in the skies over the Channel, a desperate moment-to-moment struggle where the heroic few of the RAF, in their Spitfires and Hurricanes, were just barely holding back the daylight onslaught of the Luftwaffe. But as summer bled into autumn, the battle changed. The Germans, frustrated by the RAF's unbreakable resistance in the day, pivoted to a new, more terrifying strategy, the night blitz. The sirens began to wail over London, Coventry, Manchester, a nightly soul-crushing chorus of terror, followed by the distant crump, crump, crump of high explosives and the roar of 1,000 fires. The Luftwaffe owned the darkness. They were bombing, not just indiscriminately, but with a precision that was chilling, impossible. In total blackness, through thick cloud cover, they were hitting their targets, factories, railway junctions, docks, with a navigational accuracy that baffled Allied command. How were they doing it? The conventional wisdom was that they were simply using dead reckoning, starlight, and maps, combined with the guiding light of the fires from the first wave of bombers. This was the theory held by Air Commodore Jeffrey Watson, a man of hard-nosed, practical, old-school RAF thinking. He was a pilot's pilot, a man who believed in the Mark I eyeball, in the skill of a man, not the gimmickry of a machine. He had seen the early flawed reports from the new, experimental RDF, range and direction finding systems, what we would come to call radar, and he was deeply skeptical. He saw them as a drain on resources, a boffin's fantasy. In a damp, cramped, temporary hut at a converted coastal radar station in Swanage, Dr. Alistair Finch felt like a man shouting into a hurricane. Finch was the opposite of Watson. He was not a warrior. He was a physicist, a quiet, meticulous, painfully shy man in his late 20s, seconded from the Cavendish Laboratory at Cambridge, a man who believed in numbers, in wave propagation, in the beautiful, cold logic of the electromagnetic spectrum. He was, in Watson's dismissive terminology, a boffin, and he had been assigned a job that was considered a professional dead end. Analyzing the noise floor of a new, deeply troubled, and universally hated piece of equipment, the AI Mark IV. AI, or Airborne Interception, radar. This was the failed radar. It was a bulky, primitive, 5-meter wavelength set, consisting of a heavy transmitter, a receiver, and a complex web of antennas, all crammed into the nose and wings of a Blenheim, or the new powerful Beaufighter. It was, by all accounts, a disaster. It was heavy, robbing the fighter of precious speed and maneuverability. It was notoriously unreliable, its vacuum tubes constantly blowing under the vibration of combat, and worst of all, its user interface was a nightmare. The operator, a separate crewman crammed into a dark, claustrophobic station, stared at two small green cathode ray tube displays, one showing range, the other relative bearing. But the blip of a target was almost impossible to find, buried in a constant, swirling, chaotic snowstorm of electronic noise, static, and, most frustratingly, massive, overwhelming clutter from the ground. The night fighter pilots loathed it. It was extra weight, extra complexity, and, in their opinion, completely useless. "It's junk, Reggie," one pilot had told Finch over a bitter cup of tea, using his informal name. "Absolute bloody useless junk. I spent half the night trying to tell the difference between a Heinkel and a bloody cow in a field. Most of us just turn the bloody thing off. It's easier to use your eyes." The program was on the verge of cancellation. Air Commodore Watson was its most vocal opponent. "We are wasting precious man-hours and resources on this death ray fantasy, gentlemen." Finch had heard him boom in a high-level briefing. "This AI radar is a failure. It is too noisy, too unreliable, and it has not, to date, been responsible for a single verified kill. We must scrap this program and put these valuable men and resources back into building more searchlights and training more cat's eye pilots who can actually see in the dark." For Finch, this was a tragedy. He believed in radar, but he was just a junior physicist, assigned to the janitorial task of analyzing the noise. His job was to wade through the endless, frustrated after-action reports from the AI operators, to look at their logs of static interference and unidentified noise, and to write a report recommending better shielding, or different frequencies, or something, to make the blip clearer. It was the bottom of the barrel. So, night after night, Finch sat in his cold, damp hut, surrounded by stacks of greasy, pencil-scrawled logs. He was looking for patterns in the noise. He was a man obsessed with signal-to-noise ratios. And as he plotted the reports, a strange, impossible, electrifying pattern began to emerge. The noise, the interference the operators were complaining about wasn't random. It wasn't the fuzzy, chaotic crackle of atmospheric static. It wasn't the persistent, low-level grass of ground clutter. This was different. He isolated a series of reports from 43 Squadron. The operator, a Sergeant Davies, was a meticulous note-taker. 22:17, Davies had written, "Patrolling Sector Beta, heavy rhythmic hissing interference on 1 5-meter band, constant, swamped scope, no contacts seen." 23:05, Patrolling Gamma, hissing gone, scope clear. 23:20, re-entering Beta. Hissing returned, same bearing, same strength, had to reduce receiver gain to 0, useless. Finch's blood went cold. He pulled more reports, from different nights, different pilots, but the same sectors, over and over, when flying on specific headings, west of London, or approaching Coventry from the south. The AI radar, this failed piece of junk, was being overwhelmed by a loud, steady, directional buzzing or hissing. Finch grabbed a map of southern England and a protractor. He began to plot the bearings. He drew lines, faint pencil marks, from the patrol sectors, back towards the source of the reported noise. The lines. They weren't random. They weren't pointing all over the place. They converged. They crossed. They all pointed, with chilling mathematical precision, to one specific spot on the other side of the English Channel. A spot near Cherbourg, in occupied France. It's a beam," Finch whispered, his voice a dry croak in the silent hut. "My God, it's not noise. It's a signal. It's a radio beam, a navigation beam." His mind raced, the implications staggering, terrifying. The Germans weren't just lucky. They weren't just good navigators. They were cheating. They were riding a precise electronic highway through the sky. A beam of energy pointed directly from France to their targets in England. They weren't seeing the targets. They were just flying down this invisible electronic road, and when the signal stopped, or when a second beam from a different station crossed the first one, they just dropped their bombs. That was how they were hitting the factories, the docks. It was a system, a precise, targeted electronic bombing system. He realized with a jolt that the AI radar, the failed radar, wasn't a failure at all. It was an accidental success. Its flaw, its extreme unshielded sensitivity on the 1.5 meter band, the very thing that made it noisy and useless to the pilots, was precisely what made it the only piece of equipment in all of Britain that could hear this German beam. It was a happy, brilliant, world-changing accident. The AI radar wasn't just a poor-quality plane finder. It was a perfectly designed beam finder. He had to tell someone. He ran, his charts clutched in his hand, through the rain-soaked darkness to the office of his direct superior, Dr. Abercrombie, the head of the Swanage Research Group. Abercrombie was a cautious man, a good scientist, but a man terrified of the military brass, terrified of Air Commodore Watson, terrified of being wrong. Finch burst in, drenched, manic, his eyes wild. "Sir, I found it! I found it! The noise! It's not noise! It's a beam, a German navigation beam. They're guiding the bombers. Look." He spread his map, his data, his logs, across Abercrombie's desk. "It's all here, the bearings. They all converge. Right here, in Cherbourg. The AI radar, the one they hate, it's detecting it. We can hear them." Abercrombie stared at the map, at the frantic pencil lines, at this wild-eyed, rain-soaked junior physicist who looked like he'd just seen a ghost. He looked pitying. "Reginald," he said, his voice the smooth, placating tone one uses on a hysterical child. "Get a grip on yourself. You're overtired. You're seeing patterns in the static." "No, sir. The math is sound. The bearings are consistent over weeks of data." "It's impossible, Finch," Abercrombie snapped, his patience breaking. "You're a noise analyst, not an intelligence officer. You're telling me the Luftwaffe is so stupid they're broadcasting their attack plans on a frequency our own fighters can pick up? It's absurd. It's noise, sunspots, atmospheric ducts, a flaw in the Mark V's receiver. It is not a secret German death ray." He stood up, gathering Finch's precious papers. His map. "Your job, Dr. Finch, is to find a way to filter out this hissing, to eliminate it, so the pilots can find the bombers. Your job is not to invent conspiracy theories. This project of yours is rejected. Your findings are inconclusive. You will cease this line of inquiry immediately." He handed the papers back. "Now go get some sleep, man. You look dreadful. You've been working too hard on a failed program, maybe. Maybe I should request your transfer back to Cambridge. This war work. It's clearly not for you." He had been rejected, laughed at, dismissed as a hysterical, conspiracy-theorizing rookie. The most important intelligence discovery of the war was just noise. Bletchley Park, 1942. The name now evokes images of tweed-clad geniuses, of quiet academic heroism, the ticking clock of Alan Turing's bombing machine deciphering the naval enigma. But in the cold, damp, smoke-filled chaos of Hut 6 and Hut 3, the mood was not one of triumph. It was one of deepening, gut-wrenching failure. Enigma, the easy cipher used by the German Army, Air Force, and Navy, was a known quantity. It was a daily, agonizing, intellectual street fight. But it was a fight they were, for the most part, winning. The victory, however, was hollow, because it was incomplete. There was another signal. A different signal. A code that was not the familiar rhythmic Morse of Enigma, but a strange, chattering, digital hiss. A teleprinter signal, broadcast from the highest echelons of the Nazi regime. From Berlin, from Hitler's own Wolf's Lair headquarters in Rastenburg, directly to the field marshals on the front lines, to von Rundstedt, to Rommel. The British codebreakers called it Fish. The machine that generated it they called Tunny. And it was, by every known measure, unbreakable. Where Enigma was complex, Tunney was a monster. It was a 12-rotor, online stream cipher machine built by the German firm Lorenz. It didn't just substitute letters, it used Boolean algebra, XOR logic, to combine the plaintext with a stream of 1/6 million, 1/6x10^15 possible pseudo-random key characters. The Enigma machine was a mechanical puzzle. Tunney was a fortress of pure abstract mathematics, and the Bletchley Park codebreakers, the finest mathematical minds in the world, were smashing themselves against its walls and finding nothing. The codebreakers in the testery, the unit dedicated to non-Enigma ciphers, were desperate. The intercepts were piling up, thousands of messages from Hitler himself, from the WWII High Command, detailing strategic plans, troop movements, the very mind of the Nazi war machine, and it was all just meaningless, statistical noise. The breakthrough came not with a crash of thunder, but with a whisper of pure deductive genius. A young, brilliant, and almost painfully quiet mathematician named Bill Tutt, working not with a machine, but with just a pencil and stacks of paper, achieved the impossible. By meticulously, obsessively analyzing the noise in the key stream itself, he found a pattern, a fingerprint. He deduced, without ever having seen the machine, its entire logical structure. He discovered the 12 wheels were split into two groups: 5 chi wheels that moved in a complex but ultimately regular pattern, and 5 psi wheels that moved in a much more irregular, jerky motion. This was the break. He had found the ghost in the machine. He had given the codebreakers a mathematical way in. But this breakthrough immediately created a new and even more insurmountable problem. Tuttey's discovery meant that, in theory, you could break the daily settings of the Tunney machine by comparing a captured intercept, a string of teleprinter holes on a paper tape, against every single possible starting position of the 5 chi wheels. This was a statistical analysis, looking for correlations. For a moment, when the comparison yielded not random noise, but a statistically significant deviation, revealing the key. The problem? The number of combinations was still astronomical, running into the tens of millions. Doing it by hand was impossible. It would take decades. The war would be long over. The geniuses in the testery, led by the brilliant Max Newman, knew they needed a machine. They needed a way to automate this comparison, to run the two tapes, the intercepted message tape and the key tape, representing the patterns of the chi wheels, against each other at high speed. And so, in 1943, they built their first attempt. They called it Heath Robinson, named after the popular British cartoonist famous for drawing absurd, overly complex Rube Goldberg-style contraptions. The name was a dark joke because the machine was a joke. It was a mechanical nightmare. A sprawling 50-foot-long monster of clattering relays, spinning pulleys, flickering optical sensors, and, most disastrously, 2 physical, looped paper tapes. The intercept tape and the key tape were supposed to run, perfectly synchronized, at 200 characters per second. They never stayed in sync. The paper, fragile and brittle, would stretch. It would tear. The sprocket holes would shred. The machine would run for maybe 2 minutes, then fail, the tape snapping, the entire process grinding to a halt. It was a disaster. The bottleneck wasn't the math anymore. It was the engineering. The greatest minds in Britain were being defeated by paper. They were losing the war, drowning in unreadable intercepts, all because their impossible code-breaking machine kept tearing its own tapes. The pressure was immense. The D-Day landings were being planned, and the Tunney traffic, containing Hitler's direct orders to Rommel about the defense of France, was the most critical intelligence on Earth, and they couldn't read it. In desperation, Max Newman called for outside help. He didn't call another Cambridge mathematician. He called the post office. Specifically, the Post Office Research Station at Dollis Hill, the place responsible for the other massive, complex electronic network in Britain, the telephone system. He called for a man named Tommy Flowers. Flowers was not an academic. He was not a genius in the Bletchley Park sense. He was the son of a bricklayer. He was a practical, hands-on, brilliant electronics engineer. He was a man who thought in vacuum tubes, in relays, in high-speed electrical switching. He was, in the snobbish academic hierarchy of Bletchley, a plumber. They brought Flowers in to look at the failing, tape-shredding Heath Robinson. He stood there, a quiet, methodical man, and watched the Rube Goldberg contraption clatter, shudder, and inevitably fail, ripping another paper tape. The mathematicians of the testery gathered around him, frustrated. "Mr. Flowers," Newman said, "the problem, you see, is the tape. The sprocket holes tear. We need a stronger tape. We need better pulleys. We need it to stay in synchronization." Tommy Flowers looked at the two tapes running side by side. The message tape, the intercept, yes, that was physical. It had to be. But the key tape, the one representing the chi wheel patterns, that was just a repeating, logical pattern. He turned to the assembled geniuses, men who were, by every measure, his intellectual superiors, and he said the words that would change the world. "You don't need two tapes," he said, his voice quiet. "You're trying to solve an electrical problem with mechanical engineering. It's clumsy. The key, the chi wheel patterns. That's just a signal. It's a repeating, digital pattern. You don't need to read it from a tape. You can generate it, electronically, with vacuum tubes." The room went dead silent. The Cambridge men stared at this plumber. "Vacuum tubes, Mr. Flowers?" one of them finally asked, his voice dripping with condescending skepticism. "We are running at 200 characters a second to generate that key stream in real time. To perform the Boolean logic, you'd need, what, a dozen tubes? 100? Vacuum tubes, in 1943, were known to be notoriously unreliable. They were fragile glass bulbs that burned hot and failed constantly. A machine with 100 tubes, the academics knew, would have a mean time between failure of maybe an hour. It would be useless. "No, sir," Tommy Flowers said, his voice still quiet, still respectful, but now with a core of hard engineering certainty. "Not 100. To do it properly. To read the message tape at 500 characters per second, to generate all 5 chi wheel key streams simultaneously, to store the statistical counts, and to perform the logical comparisons in real time. I calculate. We will need approximately 1,500 vacuum tubes." The silence that followed was not one of awe. It was a stunned, horrified, explosive silence, which was immediately broken by laughter. Not a chuckle. A full, unrestrained, mocking laugh. 1,500 tubes, Max Newman said, his face a mask of incredulity. "Flowers, that's not a machine, that's a fantasy. The largest, most complex electronic device in existence has maybe 150 tubes. A machine with 1,500. The statistical probability is that it would never work. It would have a tube failure every, what? 10 minutes? It would be a 10-ton furnace that produced nothing but bad data and frustration. It is impossible." The rejection was total. It was public. It was humiliating. The mathematicians, the geniuses, had declared his idea a joke. "Go back to your telephones, Mr. Flowers," Newman said dismissively. Just see if you can make the pulleys on the Robinson work. That is your job. Your electronic tape reader, your impossible machine, is rejected." Flowers stood there, his face burning, a quiet post office engineer who had just been laughed at by the greatest minds in Britain. But as he stood there, he knew something they didn't. He wasn't a theorist. He was a practical man. And he knew the secret to vacuum tubes. He knew why they failed. They failed when you turned them on and off. The thermal shock of heating and cooling was what killed the filaments. But the post office telephone exchanges. They ran thousands of tubes, 24 hours a day, 365 days a year. And they were incredibly reliable. Because they were never, ever turned off. The mathematicians, in their brilliance, were wrong. His machine wasn't impossible. It wasn't crazy. It was just big. He walked out of that briefing room, his proposal rejected, his idea mocked. He went back to Dollis Hill, and he told his own boss, "We are building it. without a budget, without an official request, without Bletchley Park's permission. He was going to build his impossible machine in secret. He was going to build Colossus. The humiliation was a physical taste, metallic and sour, like the bad tea in the Bletchley Park canteen. Tommy Flowers stood on the damp, cold railway platform at Bletchley Station, waiting for the slow train back to London, the laughter of the Cambridge mathematicians echoing in his ears. 1,500 vacuum tubes. He could still see the look on Max Newman's face, the shock, the pity, the outright derision. A fantasy. A 10-ton furnace. It'll fail every 10 minutes. They had dismissed him. They, the geniuses, the theoreticians who lived in a world of pure abstract logic, had just told him. A man who managed a network of hundreds of thousands of vacuum tubes daily. A man who understood the hard, physical, practical magic of electronics better than any man alive. That he didn't understand how a vacuum tube worked. The arrogance was breathtaking. The ignorance was catastrophic. They had looked at his proposal, the solution to their unbreakable code, the key to unlocking Hitler's own mind, and they had laughed at him, called him crazy, and told him to go back and try to put a band-aid on their shredding, failing, mechanical monstrosity. They were trying to fight a high-speed electronic war with pulleys and paper. It was like trying to stop a panzer with a musket. He felt the cold, hard lump in his pocket. It was a single, standard-issue, post-office-type 6A vacuum tube, the kind used by the thousands in telephone repeaters all across Britain. The experts at Bletchley saw it as a fragile, glass-filled blip, a liability, a single point of failure. Tommy Flowers looked at it and saw a soldier. He saw a reliable, tough, battle-proven piece of hardware that could run, stable and true, for years, as long as you followed one, simple, practical rule that the academics had never learned. You never, ever turned it off. The thermal shock of heating and cooling the filament was what killed a tube, not the running of it. The mathematicians, in their brilliant abstract calculations of mean time between failure, had assumed a world of intermittent use. Flowers lived in a world of continuous operation. His impossible 500-tube machine wouldn't fail every 10 minutes. It would, he knew, with the certainty of a man who builds, not just theorizes, run forever. He got back to his real kingdom, the post office research station at Dollis Hill. This was not a converted aristocratic mansion full of long-haired poets doing sums. This was a workshop, a sprawling, industrial, brick and steel campus filled with the sounds of lathes, the smell of hot solder and ozone, and, most importantly, engineers. Practical men who understood wiring, relays, power loads, and reliability. He gathered his team in the big, cluttered main lab. Not just his superiors, who were already nervous about the resources Bletchley was borrowing, but his real team, Sidney Broadhurst, a quiet, meticulous genius with relays, Alan Coombs, a man who thought in logic circuits, Bill Chandler. These were the men who had built the telephone exchanges, the men who kept Britain talking. They were the plumbers, the technicians, the men Bletchley Park looked down on. "Gentlemen," Tommy said, his voice quiet, his normal humility gone, replaced by a cold, hard fire. "Bletchley is failing. Their Heath Robinson machine is a disaster. It's tearing tapes. It's too slow, and they are drowning in intercepts they can't read." He laid out his plan, his impossible machine. "They want us to fix their pulleys," he said, his voice dripping with contempt. "I told them no. I told them we would build them an electronic solution. They rejected it. They said it was a fantasy. They said it's impossible. They said a machine with 1,500 vacuum tubes cannot work." He paused, looking at the faces of his men. They were skeptical, shocked. 1,500 tubes was an insane number, a machine 10 times more complex than anything ever built. "But they're wrong," Tommy said, his voice low and intense. "They are academics. We are engineers. They don't understand reliability. We do. We do it every single day. We are going to build it. We are going to build it right here. And we are going to build it in secret." This was the moment. This was the madness. It was an act of profound patriotic treason. He was, in effect, launching a black project, a rogue operation, using government resources during wartime, against the express wishes of the primary military intelligence organization, Bletchley Park. If he was caught, if Major Davids, or more accurately, Max Newman, and the Cambridge contingent found out what he was doing before it worked, he wouldn't just be fired. He'd be imprisoned. He and his entire team would be branded as saboteurs, wreckers, who had diverted precious, strategic war materials, thousands of vacuum tubes, miles of copper wire, tons of steel, all desperately needed for radar and radio production, into their own private, crazy project. But the alternative was worse. The alternative was knowing the solution and doing nothing. It was letting the T-34s, wrong story, the Allied armies. It was letting the D-Day invasion, which he knew was being planned, walk blindfolded into a Nazi buzzsaw, all because the experts were too arrogant to listen to a plumber. "We have no budget," Tommy continued. "We have no official requisition forms. We have no permission. What we do have is the post office maintenance and supply chain. We will build this from spares. We will log the time as telephone exchange upgrade research. We will lie. We will scavenge. We will hide. We will work nights. We will work weekends. But we will build this thing." There was a long silence. Broadhurst, his oldest colleague, was the first to speak. "Tommy," he said slowly, it's not just the tubes, it's the tape. Heath Robinson is tearing tapes at 200 characters per second. You're talking 500. How? How do you read a paper tape at nearly 30 miles per hour? Without shredding it? It's not the electronics, Tommy. It's the physics. It can't be done." "It can," Tommy said, a sharp, fierce gleam in his eye. "It can, because Bletchley is solving the wrong problem. They're trying to synchronize two paper tapes. That's why they need the sprocket holes. That's why the tapes are tearing, because the two drives are fighting each other. It's a mechanical nightmare." He grabbed a piece of chalk. "But we don't need the second tape. We are generating the key stream electronically. So we don't need synchronization. We just need to read the message tape at high speed. We just need to get the data in." "But at 500 CPS, Broadhurst insisted, "the sprocket holes, they'll tear out in a second. You can't pull a tape that fast." "Then we don't pull it," Tommy said, sketching frantically on the blackboard. "We don't use the sprocket holes. We get rid of them. We build a simple, smooth friction drive, a capstan roller, and we read the data, not with metal pins, but with light, a bank of photocells. A bright light on the other side. The tape flies between them. The holes become pulses of light. No contact, no sprockets, no tearing." The room was stunned. It was a solution of such staggering, simple brilliance that it was breathtaking. He had just solved the mechanical problem that had defeated Bletchley Park for a year by eliminating it. The impossible tape reader was possible. "My God, Tommy," Broadhurst whispered, seeing it. It might actually work." "It will work," Tommy said, his voice a low, hard growl. "And so will the tubes. Now, who is with me?" Not a man faltered. They were in. The war had a new secret front, Dollis Hill. The work began that night. For the next 11 months, the Dollis Hill team lived a life of feverish, organized conspiracy. They became the Bletchley Park Repair Service, their official cover, which gave them the excuse to be working on their broken Heath Robinson machine, a pretext to travel, to requisition parts. But their real work, Project Colossus, as they code-named it, was hidden behind locked doors in a massive, windowless room, Room 6, at the research station. It was a Herculean task of engineering, a moonshot project in the dark. The machine they were building was a monster. It was 18 feet wide, 7 feet tall, 10 feet deep. A massive frame of black industrial steel, supporting racks, and racks, and racks. of glowing glass bulbs. Not one, 500 tubes. They needed more for the logic, switching, and the counters. It was closer to 2,000. It was a wall of hot, humming, hissing glass, a veritable electronic furnace that consumed 8 kilowatts of power, enough to light a small village. The wiring alone was a nightmare, a spider's web of color-coded cables, so dense it looked like a cross-section of a mechanical brain. Thousands of connections, everyone hand-soldered by the team, everyone a potential point of failure. And the tape reader, the genius at its heart. It was a Rube Goldberg contraption in its own right, a massive bedstead-like frame of pulleys and motors, designed to feed the fragile paper, tape loop past the optical reading, head at a terrifying 30 miles per hour. The paper tape, traveling at 500 characters per second, flew with a sound like a ripping canvas sheet, a constant, high-pitched shh that set everyone's teeth on edge. They worked in shifts, 24/7, fueled by adrenaline, patriotism, and a profound collective spite. They were the plumbers, and they were going to show the geniuses how it was done. The pressure was unimaginable. The tiny intercepts were piling up, unread. The D-Day planners were blind, and Tommy Flowers knew. He knew in his bones that the key to Hitler's Atlantic Wall strategy was locked in those unreadable messages. He drove his team like a man possessed. Finally, in December 1943, after 11 months of secret, Herculean labor, it was done. The monster was ready. It was a pulsing, humming, hot wall of forbidden technology. Tommy Flowers, his hands shaking, picked up the phone. He called Max Newman at Bletchley Park. He didn't say, "I told you so." He didn't say, "I defied your orders." He just said, his voice a quiet croak of exhaustion and triumph, "Professor Newman, about that electronic tape reader. I think you should come down to Dollis Hill. I've got something to show you." Professor Max Newman arrived at the Dollis Hill Research Station on a cold, gray December morning, his face a mask of irritable academic skepticism. He was not alone. He had brought with him C.E. Tester Keene, the hard-nosed, practical mechanical engineer who ran the testery and who, more than anyone, despised the failing Heath Robinson. They were not there for a miracle. They were there, as Newman had curtly stated on the phone, to assess the salvageable components from Flowers's failed theoretical experiment, and to, once and for all, put an end to this distraction so Flowers and his team could focus on the real problem, making the pulleys on Heath Robinson stop shredding paper. Tommy Flowers met them at the door, his face pale, his eyes red-rimmed from lack of sleep, but with a new, hard, almost defiant set to his jaw. "Professor Newman, Mr. Keene," he said, his voice quiet. "Thank you for coming. It's not a fix for the Robinson. It's a replacement." Keene let out a short, sharp, disbelieving laugh. "A replacement, Flowers? We've been at this for a year. And you've built a replacement? In secret? With what? Rubber bands and paper clips?" "No, sir," Flowers said, his voice flat. He turned and unlocked the heavy metal door to room 6, with vacuum tubes. He pushed the door open. The first thing that hit them was the heat. A dry, baking wave of heat, like opening an industrial oven, a blast of energy that was shocking in the damp, freezing cold of the English winter. The second thing was the sound. A low, powerful, continuous electric hum, the sound of thousands of filaments glowing, of massive power transformers engaged, a sound of immense contained power. And the third thing, the thing that made both Newman and Keene physically stop in the doorway, was the sight. It was a monster. It was a wall of black, industrial steel, 18 feet wide, 7 feet tall, and 10 feet deep. It was not a machine. It was an installation. Rack after rack, row after row, of glowing, pulsing vacuum tubes, hundreds upon hundreds of them, thousands of them, each one a small reddish-orange beacon, casting a demonic flickering glow across the room. It was a massive, humming, hot, alien brain, a 10-ton furnace, just as Newman had predicted. Good God. Flowers, Newman whispered, his academic skepticism momentarily shattered, replaced by sheer, stunned horror. You actually built it? The 500-tube fantasy? 2,378, sir, to be precise, Flowers said, his voice calm. He gestured to the sprawling U-shaped monolith. For the logic gates, the 5-channel chi wheel simulators, the statistical counters, and the timing pulse generator. This is Colossus. Keene, the practical engineer, recovered first. His shock turned to immediate professional scorn. Flowers, this is a crime, he hissed, his eyes scanning the massive hand-wired racks, the miles of color-coded cabling. The tubes, the copper, the steel, all diverted from the war effort, from radar, for this fire hazard? I told you, Newman, he said, turning to his boss. The man is a madman. It's a statistical impossibility, Newman said, his own anger rising, his face flushing. A machine of this complexity, 400 tubes. It will never be stable. The mean time between failure would be minutes. You've built the world's most expensive and most illegal room heater, Flowers. You're wrong, sir. Flowers cut him off, not loudly, but with a hard, cold certainty that stopped Newman cold. You're wrong, because you're thinking like a mathematician. You're thinking of intermittent use failure rates. You're thinking of the radios you turn on and off. Those are the tubes that fail from the thermal shock of heating and cooling. He patted the hot black steel frame of his creation. We are engineers. We build telephone exchanges. We build systems that run for decades. The secret, Professor, the secret we know and you don't, is that you never, ever turn it off. He pointed to the massive, humming power supply in the corner. This machine has been on, in a stable, warm state, for 72 hours straight. We've had 2 tube failures, total. It is the most reliable piece of electronic equipment on this planet. Newman and Keene were speechless, their primary, theoretical objection vaporized by a simple, practical truth they had never considered. But the tape, Keene stammered, latching on to the next problem, the one that was his domain. The tape shredding. Heath Robinson tears them at 200 CPS. You're talking 500. It's a physical impossibility. You can't pull paper that fast. The sprocket holes. So we don't use them, Flowers said simply. He led them to the side of the machine, to the part that looked like a giant metal bedstead. A massive frame of pulleys and capstan wheels. You were trying to solve the wrong problem, Mr. Keene. You were trying to synchronize 2 paper tapes. That's what Heath Robinson does. That's why it needs sprockets. That's why it fights itself to death. He pointed to the racks of tubes. My key stream is electronic. It's generated in here, so I don't need to synchronize anything. I just need to read the message, tape, fast. He showed them the reader. It was a work of genius. A simple, smooth, polished steel capstan, driven by a powerful electric motor that would pinch the paper tape and feed it. No sprockets, no pulling. Just a smooth friction drive. And the reader? Keene asked, seeing no pins. Here, Flowers said, pointing to a small shielded box. Optical, a bright light on one side, a bank of high sensitivity, photocells on the other. The tape flies between them. The holes become pulses of light. No contact, no friction, no tearing, just data, at 5,000 characters per second. Keene just stared. He was beaten. This plumber had just solved the 2 impossible problems that had defeated Bletchley Park for a year, one by running it hot, the other by using light. It's a theory, Flowers, Newman muttered, his last line of defense, a massive illegal theory. No, sir, Flowers said. He held up a small curled loop of paper tape. It's a machine, and it's waiting for a problem. He held out the tape. This. Intercept mackerel. 0300 this morning. from Berlin to Army Group South. The one the testery has been trying to break by hand for 6 hours. The one you can't break. He looked Newman dead in the eye. Give me 1 hour. The air in the room was so tense it was vibrating. Newman, his career, his reputation, his entire scientific worldview, at war with his desperate, crushing need for a breakthrough. Finally, slowly, he nodded. Keen, give him the tape. The two Cambridge men stood back, their faces a mask of skepticism and a new, dawning fear, as Flowers and Broadhurst meticulously threaded the fragile paper loop onto the massive bedstead. Tape is set, Broadhurst reported. Flowers looked at his creation, a father looking at his child on its first day of school. Engaging drive motor. Now, a heavy clunk, and then the sound of a canvas sail ripping in a hurricane. The shh of the paper tape accelerating, a flesh-colored blur, to 30 miles per hour. The Bletchley men flinched, expecting it to disintegrate into confetti. It held. Optical reader is live. Coombs called out, "We have a clean data stream." Engaging logic circuits, Flowers said, his voice a low command. He threw a series of heavy, black switches, and the sound in the room changed. The low, steady hum was joined by a clatter, a frantic, deafening, castanet-like sound, like 1,000 skeletons typing at once. It was the sound of the high-speed relays firing, of the electronic adder circuits, of the 5-channel statistical counters. It was the sound of the machine thinking. A wall of small, neon lamps, the counter display, began to flicker, a chaotic, dazzling, incomprehensible dance of light. The machine was not just running, it was calculating. It was performing millions of Boolean logic comparisons, character by character, against the electronically generated key streams of the chi-ear wheels. Newman and Keene were just staring. They were witnessing a process that, just yesterday, they had declared a statistical impossibility. Their own Heath Robinson was a clattering, slow, tape-shredding abacus compared to this lightning storm in a box. The heat from the 400 tubes was intense, a dry, baking wave. The smell of hot ozone and metal was overpowering. The sheer violence of the computation, the speed of it, was mesmerizing. This was not a calculator. It was a brain. It's running, Keene whispered, his voice full of awe, his earlier mockery forgotten. But is it finding anything? Flowers said nothing. He just watched the counters, his eyes scanning the flickering neon lights. The machine was brute-forcing the first set of wheel patterns. Statistical noise. The second. Noise. The third. Minutes stretched into an hour. Then 2. The Bletchley men were pacing, nervous. Maybe it was just a furnace. Maybe it was just a fast way to get a wrong answer. "Mr. Flowers," Newman said, his voice tight. "It's been 2 hours. If it hasn't found a deviation by now..." "Shh," Broadhurst hissed, his hand up. He's staring at the bank of counters. "Tommy, look. Counter 3. The delta. It's climbing." Flowers rushed to the panel. The neon lights, which had been a random flicker, were now showing a pattern. One of the statistical counters, the one measuring the correlation for the third chi wheel, was climbing past the threshold of random noise. It wasn't just a blip. It was a signal. "That's it," Flowers breathes, his voice shaking. That's the setting. Wheel 3. It's a hit. We've found it." He hits a switch. The machine clatters to a halt. He grabs a pad, scribbles down the results, the wheel settings that produced the statistical spike. He hands the paper to Keene. "There, sir. That's your key. Run that setting on your Robinson. Or, hell, do it by hand. That's the chi wheel setting for the mackerel intercept." Newman and Keene are frozen. They are staring at the piece of paper as if it's a burning coal. This post office engineer, this plumber, this madman, in 2 hours, with his impossible 10-ton furnace, has just done what their entire testery of geniuses couldn't do in weeks. He hadn't just broken a message. He had broken the system. He had created an automated process for finding the key. Newman, his face pale, his voice hoarse, looks at the massive, humming, hot machine and then at Flowers. "My God, Flowers," he whispers, his intellectual snobbery, his skepticism, his certainty, all vaporized in the heat of those 400 tubes. What do you call this thing?" Flowers, allowing himself a small, tired, victorious smile, just pats the hot steel frame. "We call it Colossus, sir. The impossible machine was born, and the war, the Shadow War, was about to change forever." The scene in Room 6 at Dollis Hill was a watershed moment in human history, though only 4 men knew it. Professor Max Newman, the brilliant Cambridge mathematician, stood pale-faced, the printout of the mackerel key settings trembling in his hand. He was staring at the massive 400-tube behemoth, its racks of glowing glass bulbs hissing with heat, a 10-ton furnace that worked. Tommy Flowers, the plumber, the post office engineer he had laughed at, had not just built a fantasy. He had built a miracle. He had built a brain. The rejection was over. The war was on. "Flowers," Newman said, his voice a hoarse whisper, the academic arrogance completely gone, replaced by a raw, desperate urgency. This changes everything. We need it. We need it now. At Bletchley. Yesterday." The secrecy was absolute. Colossus was disassembled, its massive steel frames, its miles of wiring, its thousands of tubes, labeled with cryptic, innocuous markings. "Telephone exchange repeater, Unit 15. It was moved under cover of darkness, a black project so secret that even most of the Bletchley Park staff, the Enigma code breakers in the neighboring huts, had no idea what it was. They just knew that the post office madmen were building some monstrous new Robinson in Hut F. Colossus Mark I was reassembled at Bletchley Park in January 1944. It was turned on, and, as Flowers had promised, it stayed on. It began to eat. The backlog of unbreakable Tunney intercepts, the thousands of messages from Hitler, from von Rundstedt, from the High Command, were fed into its optical reader. The 30 Mabry paper tape, a blur of motion, flew past the photocells, and the Colossus, clattering, whirring, its 400 tubes glowing hot, its counters flickering, began to think. It did in hours what had taken Tutti and the testery months of agonizing hand calculation. It ripped the chi-wheel settings out of the sky. Suddenly, Bletchley Park wasn't just reading the Enigma traffic. They were reading the mind of Hitler himself. The intelligence was staggering, but the timing was critical. D-Day, the invasion of Normandy, was just months away. The entire Allied strategy hinged on Operation Fortitude, a massive, elaborate deception plan to convince the Germans that the real invasion was coming at Pas-de-Calais, not Normandy. This deception was designed to hold Hitler's most powerful, most lethal reserves, the 1st SS Panzer Corps, the 116th Panzer Division, in reserve at Calais, away from the Normandy beaches. If those panzers were at Normandy on D-Day, the invasion would be a bloodbath. It would fail. The Allies were desperate to know, did Hitler believe the lie? The answer was locked in the Tunney traffic. As spring 1944 bled into May, Colossus, clattering away 24/7 in Hut F, provided the answer. It decrypted in near real time messages from Hitler to von Rundstedt, the commander in France. The intercepts were undeniable. Hitler was obsessed with Pas-de-Calais. He had swallowed the bait, hook, line, and sinker. But the Germans weren't stupid. Sensing something was wrong, their messages were being acted upon too quickly. They changed the procedures. They changed the PSI wheel settings more frequently. The other 5 wheels, the ones Bill Tutt had identified as irregular, Colossus Mark I, which only automated the chi wheels, was suddenly struggling. The process was too slow again. Newman went back to Flowers, not with skepticism, but with pure, desperate need. "Tommy," he said, "it's not enough. You found the chi wheels. Now, you have to find the PSI wheels. You have to automate the entire brake, and you have to do it by June 1st. It was an impossible deadline. Flowers and his team at Dollis Hill didn't just modify Colossus, they built a new one. The Colossus Mark II. A 500-tube beast, faster, more complex, incorporating new logic circuits specifically designed to deduce the PSI wheel settings. It was an order of magnitude more complex. They built it from scratch in 5 months. It was delivered to Bletchley, still in pieces, on May 31st. They assembled it in a frantic, sleepless days. It was switched on, for the first time. On June 1st, 1944, it worked. And on June 5th, 1944, just hours before the 101st Airborne was set to drop behind enemy lines, Colossus Mark II, Tommy Flowers' impossible machine, decrypted the single most important message of the entire war. A tunny intercept from Field Marshal von Rundstedt to Hitler, giving his final assessment of the Allied fleet massing in the Channel. He stated with absolute certainty that the Normandy landings, which he believed were imminent, were merely a diversion. He was convinced the main attack was still coming at Pas de Calais, and in response Colossus decrypted Hitler's reply, an order forbidding the release of the panzer reserves at Calais to move towards Normandy. He was holding them back. The deception had held. General Eisenhower, when he saw that intercept, that golden egg, knew. He knew that when his men hit the beaches at dawn, the panzers would not be there. He gave the order, "Let's go." The D-Day landings were a success, a bloody, horrific, but successful operation. The beachheads were established, the foothold in Europe was won, and it was won, in no small part, because a quiet post office engineer, a plumber, had been mocked and rejected by the geniuses. His crazy idea, his 10-ton furnace, had provided the critical war-winning intelligence that saved the invasion from certain disaster. After the war, the story was buried. Colossus and its 10 H-sister machines built by the end were deemed too secret, their very existence a threat. Churchill ordered them destroyed, broken into pieces no larger than a man's hand. The blueprints were burned. Tommy Flowers and his team were sworn to in secrecy so absolute it was binding until death. They went back to the post office, their names, their contributions, erased from history. The men who had really invented the digital, programmable, electronic computer, the machine that would define the 21st century, were forbidden from ever speaking of it. They were the true forgotten heroes. Tommy Flowers, the man whose impossible code machine had outsmarted the enemy and saved the world, went back to his quiet life, a crazy inventor whose secret was finally decades later declassified, revealing the truth, that the rejected technician had, in fact, changed everything.